Hello. Can you hear me? Can you hear me now? Okay. All right, where are we here? We're here on March 8th, and this week we're going to talk about user interactions and animations. So last week, all we did was we put graphic stuff on the screen, but we didn't do anything with it. Now we're going to start to add actual, where the users can interact with those objects, and we'll do that today. On Wednesday, we'll talk about animations. And so some of you have games where things move around on the screen. That's going to be an interesting lecture for you guys. Homework 5 is due tonight. I did not get a lot of questions over the weekend, so I trust that things are going well with that. And then P3 is going to be due on the 19th. I'm still grading P2s. I got a bunch of them done over the weekend. I'll keep working on those till they're all done. I'm trying to give good feedback on those. P3, 4, 5, and 6 all have an associated assignments, which are the peer reviews. I've broken you guys randomly up into groups of 3 and discussion boards, and you are to post your work on the discussion board and get feedback from 2 other people. I talked about that a little bit last week. The thing that's unique about P3 is turn in your, not to me, but turn in your draft article on the discussion board by Wednesday the 17th. And that way they have 24 hours to review it, and you have another 24 hours to incorporate any helpful comments that people made. And again, why am I doing this? I want you to get used to showing your unfinished work to people. That's what happens in the real world. I want you to start to appreciate how to review other people's work. That's what happens in the real world. And in the end, you should get an improved product, right? This is all about trying to improve the product. And let's see, I'll have the P2s graded well enough where you can hopefully benefit from those comments. All right, let's see, let's go through the Java interactions. Not very many outcomes this week because they're kind of great big fat outcomes. And basic process. Here's what you're going to see. First of all, we're still using the model view controller pattern. So the model, that's the actual thing. That's the math model. That's the data. That's the actual thing. The view is the presentation of the model to the user. And then the controller is the interface between those 2 things. So the user has a view of something on the screen and they interact with it in some fashion. That triggers the controller, and the controller says to the model, hey, the user wants you to do this. The user wants you to change the model. Then the model changes, and then the view has to be updated to represent the new model. So create the model, create the GUI. Some people like to create the GUI first. Some people like to create the model first. Doesn't really matter. And then you assign on your GUI, you assign actions to some of the objects on the screen. And the easiest way to do that, and here's the example with the buttons, BT my button set on action. Okay, so again, once you create your buttons, you name them, or I should say you name them while you create them. And for buttons, I use the form of BT for all my buttons. So when I'm just looking through code, if I see BT something, I know it's a button, and the something should tell you what the thing does. So BT my button is a horrible name because we don't know what that button does. But this is the form you use, BT my button dot set on action. Now, what's the action? For a button, the action is a button click. You can do all kinds of set on mouse click, set on mouse over, set on mouse release, set on key press, all kinds of actions. For buttons, it's generally set on action. And then inside the parentheses, you do this E, arrow, and then the name of the method you want to fire off. That's the name of the method you want to execute. If you have more than one method or more than one line of code that you want to execute, no problem, put them in curly brackets. Why E? E stands for event. And so Java uses E for events of all kinds. So here's a simple example. We'll do 2 examples today. I did this basic flood map program. This actually came from a project from about 3 years ago. I thought it was a great idea for a project. Student wanted to do a terrain map and then study how the terrain was affected when flooding occurred. And so they start out with a terrain map and then they can raise and lower the water level. They were doing it in the context of sea level rise. It doesn't matter. It could be dam bursts. It could be, hurricane rainfall. But the idea is, you want to see how the map changes as the water goes up and down. And the way the map's going to change is some of these things turn blue, right? Anything underwater turns blue. So we'll walk through this example. And how does that change the process? Well, we need to tie the actions to the buttons. So you see those 4 buttons there, 0 meters, 3 meters, 5 meters, 8 meters. The process that I was mentioning to you last week was this: you build all your nodes, and the buttons are nodes. You build the pane and put the buttons in the pane, and then you put the pane in the scene, put the scene in the stage and show. And we're just going to add one thing to it. You build all the nodes, like the buttons, and you add an action to the button. Then you add it to the pane. Then you add the pane to the scene to the stage. So we're just putting one more step in that process, which is to add all your actions in. And it looks like this. So for that first button, which was the 0 meters of water, I made 4 buttons and I named them BT0, BT3, BT5, BT8. I thought that would be a good enough mnemonic to remind me what the button did. So I create button BT0, and notice I have to give it a name, right? So we saw some examples earlier where the buttons didn't have names. Here the button has a name. Why? Because I need to grab it later, and I can't grab it without a name. I need to grab it later to both set its location and to assign an action to it. So lines 102 creates the buttons. 103 and 104 positions the buttons. We'll talk about why 104 looks the way it does later. And then on line 105 and 106, that's where I set the button action. BT set on action, E for event, arrow, and then I run 2 methods, color the rectangles, color the water level. And then once I'm done with that on line 108, I add the button to the pane. Now, where's that arrow come from? It's a negative sign greater than sign. And why is it an arrow? I don't know. It's an arrow. It could be that people when they talk about computer science theory, they often use arrows to show like transformations, like input, arrow, output. Possibly, who knows? Maybe maybe it was midnight and everybody wanted to go home, so they said, arrow. But it's that easy. There are at least 2 other methods that the author presents in the text, and I think you'll see one of them in lab, where you add listeners or you add action events as separate classes. I find those to be, I think they're outdated. That's the older way of doing things. This form came in with Java 8, so it's a relatively recent development. To me, it's clean. It reads well. I can understand what's happening. So that's my preferred method. If you want to do it another way, do it another way. But the bottom line is you have to add the method that gets executed. When the button's pressed, you have to add that method or tie that method to the button. Okay, so let's look at some code examples for this, and then we'll talk about transitions and animations on Wednesday. Questions so far? Okay, loan calculator. There's a loan calculator. Before we look at the code, let's guess at what the code looks like. Notice how nice and pretty the thing is laid out. What do we expect to see in the code? What kinds of things are we going to see?
Say about like 5 text field nodes.
Yeah, we've got text fields, right? And each text field is associated either with a text or a label, depending on what they chose to use. So we know we're going to see 5 labels and 5 text fields. And a button, right? How did it get laid out so pretty? Couple ways. They either positioned them or they used a grid pane. And the fact that I can move it around and it moves and it stays cohesive and right, I'm going to go with grid pane. Plus I already know because I looked at the code, right? I'm going to go with grid pane. How about the loan? I put in ta-da. It actually did something this time, right? Before, when we clicked the buttons, nothing happened. Now something happened. We have actual user interaction. How do you think they built the loan? Let's see. Let me ask you a better way, maybe a better way. How many files do you think you have here? We have certainly a file to create the GUI. Is there a separate class for the loan or not? How would you do it? You're opening up that zip file, aren't you, to see what's in there. Here's the way the authors did it. They have a loan calculator and a loan. The loan is its own class. It's its own object, which I like because what are they doing? They're sticking with the model view controller pattern. The loan is the model of the loan. You know, if I said to you, oh, here's a loan, what would you do? Well, you'd say, well, let's see, if I want to have a loan, what do I need to know about the loan? Those become your attributes. What do I need to, what kinds of questions would people ask about the loan? Those would be the methods. And here it's pretty easy. You know, what would you need to know about the loan? Well, we know we need to know interest rate, length of loan, and initial amount that was borrowed, loan amount. Those 3 things. Now, we might be able to think up more, but those 3 things. And then what would you ask about it? Well, as a minimum, you know, we know we're going to ask monthly payment. We know we're going to ask total payments. So there's 2 methods. So sure enough, here's annual interest rate, number of years, loan amount. Those are things that you absolutely have to know about the loan in order to answer questions about the loan. Now they're saying, let's see, the annual interest rate, number of years, loan amount, and they do loan date, which oddly enough, they never use in the program. So, you know, we could get rid of that. You have to ask yourself, you know, did I catch all the attributes? Are there any attributes you could get rid of? Are there any attributes that should be added? Like monthly payment, isn't that an attribute of a loan, monthly payment? Should I add monthly payment as an attribute? What do you think? No, the payment is based on time and principal. In other words, Sean is saying, no, the payment is based on time and principal. In other words, you can calculate it. And what's my general advice to you guys? If you can calculate it, don't store it. If you can calculate it, don't make an attribute for it. So you have a calculate monthly payment or whatever they called the method, whatever they called the method for that. So you don't need it. You can get it anytime you want by performing the calculation again. Is that wasteful? Is that wasteful in terms of computer cycles? Is that inefficient? Sure it is. So why would I say that that's what you should do? Is there any benefit to it?
Guess you don't risk accidentally changing the value.
Exactly.
Like
So if I stored the monthly payment as an attribute and then I change the terms of the loan, but now I've made an opportunity for myself to screw up because I may not remember to change the monthly loan payment value. Well, you would never do that. Okay, that's fine. Maybe you wouldn't, but remember, software, especially in the commercial world, and unfortunately we don't get to experience this in the academic world very much, software lasts longer than one semester, and it gets worked on by more than one person. So what happens is you create this thing, they send you, your company sends you to do another job, and then someone else comes on and has to finish, has to keep upgrading and maintaining your software, and they may not know that when I change the interest rate, I have to automatically change the monthly payment, because that's really not an intuitive thing. So again, don't store it. It gives an opportunity for errors to be introduced in the code. Whereas if you are calculating it each time based on the core things that you need for a loan, interest rate, number of years, and loan amount, those are the core things you need to describe a loan. Everything else can be calculated and you won't make errors. Now, is it wasteful? Yes. Do we care? Not so much. Chips are super fast these days. So you rarely get into a situation where things are so time critical that you have to worry about computation cycles. And if you do, then you do things differently. But in our world, it probably didn't matter, that 4 or 5 picoseconds difference probably didn't matter to the user when they got their loan value back. So it looks like this was fairly well designed. Now, once we get past this, they have some constructors. Basically this one, by the way, I don't like the this keyword. Try to stay away from it. So public loan, they're saying set this using these default values. And if you don't use those default values, then someone can construct a loan using the individual values, using the specific values. And all they do is fill in those attribute values. Then they have all the setters and getters, get, set, get, set, get, set, get, set. Remember, for every attribute, you want a setter and a getter. That's almost always true. Is it tedious to do those? Yeah, there was only 4 attributes, so they've got 8 methods, all of which are pretty tame. Remember, Eclipse has a wizard that will create those for you. And then they have these methods here, find the monthly payment, get monthly payment, and get total payment. So those are the only real 2 methods that this class needs to worry about. Now, style points. Those are the only 2 methods that do anything interesting, right? The rest are setters and getters. I put those methods first, and I put all my setters and getters below that. Why? Because if I want someone to read through my code and understand what it does, and remember, that's what a lot of this is about, writing for humans so humans can understand it. I put those first so that when someone wants to see what that class does, they're looking at the interesting stuff first. They don't have to wade through all the setters and getters. That's style point number 1. Do you have to do that? No. Style point number 2. Here's the get annual interest rate getter, and there's a comment that says return annual interest rate. Here's a set annual interest rate getter, and there's a comment that says set annual interest rate. What do you think of those comments? A little redundant, don't you think? if you're going to name, first of all, we all know what setters and getters do. So the comment, the name of the method is already telling you what it does. And secondly, again, when the method is named appropriately, you don't necessarily need a comment to say what it's doing. I know what get annual interest rate does. In fact, I would be shocked if it wasn't there, right? If I see a bunch of attributes, I know that there's going to be setters and getters for each attribute. It won't puzzle me to see that. What will puzzle me is if I don't see it. So these comments, I would say, I would kill them all. I would even kill this one because I can see what's happening. It's clearly a constructor with the 3 input parameters. So those are just style notes. Okay. So this is the model. And now we need a view to go with the model. What do we think the view is going to look like? We already said it's going to have a bunch of text fields. It's going to have a bunch of labels. They're going to put them in a grid pane. And then they're going to have a button, and they're going to tie that button to an action, which is to calculate the values. So if we look in here, sure enough, now, look what they did. Text field, private text field, line 12, private text field, TF annual interest rate. Now notice the mnemonic, TF to remind you it's a text field, annual interest rate, because that's its job. It holds the annual interest rate. So take private text field, TF annual interest rate equals new text field. Is that an attribute or is that a variable? How would I know if it's an attribute? It's an attribute. Why are you right, Kent? You're right. Why? How do you know? Private. Why else do you know? I could have done that still to a variable too. But it is good that all of our attributes are private. How do we know it's an attribute, not a variable? New. Now we know it's an object, right? We know that we actually made a text field. So we have an object of the text field class. That's correct. That's new. But we could have done that with a variable. How do we know it's an attribute? It's outside of all the methods. There you go. Right. It's outside of all the methods. That's how we know it's an attribute. The fact that it's private is good. It means they did the right thing because you should make all your attributes private. And the fact that it says new text field means that when you create this object, you automatically get that text field created as an object. As opposed to this, grid pane equals new grid pane. That's inside the start method. That's a variable. I probably would have made it an attribute just because I'm paranoid. So what do? They create a grid pane, they set their spacing, and then they build just what we thought they were going to do. They do the label, text field, label, text field, label, text field, just like we thought they were going to do. And notice they gave the text field names. In some of the previous examples, I said, oh, the author didn't give these things names. Oh, but now we have a name. Why did they name all the text fields? Remember, a name is a handle to an object, right? If I create an object with no name, does it have a handle? No handle. Can I ever access an object that has no handles? Remember we did that diagram a while ago with the handles, right? So if I don't have a name for it, I don't have a handle for it. If I don't have a handle for it, I can't access it. Do I need to access those text fields? Absolutely, because I need to pull data from them. Whoa, I didn't. This computer is so helpful. So for these first three, I need to pull data from them. And for the last two, I need to push data to them. And I can't do that unless I can grab them by their handle, by their name. So all of these need names. My advice, name all your nodes. Because you might in the future, even though you're thinking, oh, I don't need to grab that thing. In the future, you might need to. Now notice they didn't name the labels. They just created them in place there, and that they don't give them a name. Probably a safe bet. However, if you build a label and you think you need to move it around on the screen ever, you need to give it a name so you can set its position. You think you need to change the contents of the label, change what it says, you need to give it a name. This is a pretty safe bet that they didn't need to name those labels. I still might because I'm paranoid. You know, I never know what I'm going to do in the future. Okay, so they added all those things to the grid pane. Now they've got their button BT calculate. And then they just did some, setting up some alignment stuff. I always completely ignore this until I get into, oh my God, I need this to be in a certain position, and then I freak out and look at stuff like this. But here's the key line right there. Look at that. BT calculate set on action. So what did they do? They tied a behavior to the button. And what do you think that calculate loan payment is going to do? It's going to go to the three text boxes where you had to fill in values, interest rate, period of loan, and loan value. It's going to go to those three text boxes and grab the values from them. It's going to take those values, shove them down into the loan object, and tell the loan object to, hey, give me what they asked for, monthly payment and total payment. Give me the monthly payment and total payment, and then shove those two values into the text boxes for that. So how do you pull things out of a text box? How do you push things into a text box? It's going to be not shocking. Here's my calculate loan value, loan payment. And the first thing they do is they pull from TF annual interest rate. And look at that, TF annual interest rate dot get text. What a surprise, get text will get the text of what's in that box. And by the way, everything you get out of a text box is text. Everything. So even though I put in 4.00 and all of us are thinking numbers, it comes in as text. And then we have to turn it into a number. And so that's what double.parseDouble is all about. How do you learn these things? Well, first of all, you pull it out as text and you try to add it to something and you get a type error because it says you can't add text, you can't multiply text together. So you look at examples like this, or you find out, oh shoot, everything that comes in is text. That's true of the console input, text fields, everything comes in as text. And then it's double parse double. They take that text and they try to parse it as a double. If you don't have a double, the parse will crash. So here I've got 15.00. That's okay, that's a double. I can even take 15 and that can parse as a double. What I can't do is that. And if we look on the screen here, oh my gosh, big crash. Okay. Try to break the code. Okay, same thing with the years, but this is an integer, so it comes in as text. We convert it to an integer. Then the loan amount comes in as text. We convert it to a double. And then they make a new loan object right there. So notice they don't keep a loan object as an attribute of the class. That's fine. You could do it either way. They build this loan object within this method, which means as soon as this method is done, remember, all your local variables, whenever you run a method, all your local variables get destroyed when that method is completed. So what happens here, we create a loan object. Once the method is completed, that loan object gets killed. Every time I push the calculate button, I get a new loan object created and killed, created and killed. Created and destroyed. So now the loan object is going to give us the monthly payment and the total payment values. And how do we do that? We ask the loan model to tell us what the monthly payment is. And then we push it into that text box using set text, get text to take the text out, set text to put the text in. It acts just like It acts just like a print statement, but they wanted to format it. So string.format. Remember, string is an object and it has a format method. So they're going to format it. And that %.2f would look familiar to those of you that took the C class where you can do formatted output. How do they format in MATLAB? I can't remember. Is it a similar thing? I can't recall because I never work with MATLAB. It's a pretty standardized way of formatting. Yeah, Fortran, C, MATLAB. I don't know. I suspect Python does the same. Why? It started a long time ago. Everybody likes it. There's no reason to change it. And you don't have to learn anything new if you go from language to language. So that's all that is. Get text and set text. Now, when you get the text, you have to convert it into the type of data you need. When you set the text, you probably want to format it. Pretty straightforward once you're going through and understanding what each piece part does. But notice the overall thing, the larger methods here, the larger lessons. We've got a model and a view, and then that button serves as the controller between the two. And then how do you create the view? You create your nodes, you tie the node to an action. In this case, we only tied the button to an action. And then you put the nodes in the pane, and the pane in the scene, and the scene in the stage. So it's this basic process. If I were to, this is straight from the author. I haven't rewritten any of this stuff. If I were to grab hold of this and rewrite it, I would take all this stuff here and put it outside the start stage. I would make methods to do that. I like that. I like it with the start stage is small. Okay, let's get into the flood map example. So in the flood map example, I've got two versions. I've got the non-interactive version. So here you're just going to see the flood map with no interaction. Right, so there it is. And what you're going to see eventually is this, where I added some buttons where we can change the water level. Pretty simple interaction. Okay, so my terrain map is nothing more than, you've seen maps of elevations of terrains, and the terrain has different colors based on the elevation. And I just took and kind of smeared out it's not continuous. I smeared out the elevation. So I have a block of terrain at the same elevation, a block of terrain at the same elevation. So if this were in 3D, it would look like a bunch of little, cubes of different height or prisms of different height all next to each other. Okay, so let's construct this thing. What do you expect to see? When you're looking at my code, what do you expect to see? First of all, are you looking at the terrain? This is terrain with different height. Each rectangle of a different height has a different color. Are you looking at the terrain? What do we think? Yes, no, yes, no. Is that yes, you're looking at the terrain? You know it's a trick question, right? You are looking at a representation of the terrain. The terrain needs to be in a model. It's a math model away from the screen. That's the terrain. This is just a picture of the terrain. It's a representation or a view of the terrain. Remember, the thing on the screen is never the thing. So we're looking at a representation of the terrain. So I must have a terrain model and a GUI that presents the view and a controller that bridges the gap. We're always going to have those three things. Now, what would a terrain model look like? Well, all I need is to understand the average height. Let's start easier. What do you think the GUI is made up of? What's my GUI model look like, do you think? How would you do it? What does it look like to you?
We'll probably make like a bunch of changeable like colored squares.
Yeah, I made a bunch of squares and I colored them based on terrain height, which we'll get to later. Yeah, so it's a bunch of colored squares. Now, what's a better word than a bunch of? How do you get a bunch of data in one thing?
An array?
It's an array, right? Is it a 1D array or a 2D array?
$2D.
It's a 2D array. It has rows and columns. So I have a 2D array of rectangles. Now, that's the presentation. That's the view. What do you think the model looks like? Now, the model, here's how this works. Excuse me, terrain is often modeled in something called a post map, like a post in the ground. And what you do is you take the elevation, let's go with a kilometer by kilometer square. You take that kilometer by kilometer square and you take like satellite data and you average out all what the average height of that terrain is, and you put a post in the ground at that height. And then you do that for the next one and put a post in the ground, and the next one, and you put a post in the ground. It's called a post map. So if you can imagine that you had flat ground, but then you had posts of different heights. And then what would happen if you threw a blanket over it? You'd get this lovely terrain look, right? That's how they really do it in simulations. So we have a post map, and all my post map is a 2D array of numbers where each number represents the height, the average height of that square of terrain. Now I have a one-to-one correspondence. I have a 2D array of numbers, and I fixed it so they could only have a height between 0 and 10, integer based. And then I have a 2D array of rectangles. And to figure out what this rectangle should be colored, I go to the corresponding number in the post map and I say, oh, it's a 3. A 3 gets this color. And then I go to the next rectangle, go to the corresponding number in the map. Oh, that's a 7. A 7 gets that number. And I just randomly created the heights of the posts. Okay, so I've got a model, which is my post map. I've got a view, which is my rectangles. And then I'm going to need a controller. Now, I don't have a controller here because I didn't put the buttons in yet. So basically, all I can do right now is randomly create an array of post map, and then I can color it. That's all I can do with this. This is my non-interactive version. If we look at the code, your post map, pretty straightforward. All I need for attributes is the 2D array of posts. And then for methods, let's see, I want to be able to initialize this thing, and I'm just making it random, right? So I have make random map. And then I probably want to get and set individual elements. So I created a getter and setter for individual elements. Right? This is the kind of design you have to go through when you're creating your own code. What attributes do I need? What methods do I need? How do you answer that? What methods do I need? Well, you try to imagine what are technically called use cases. How will this object be used? What questions might people ask of this object? In this case, since I know that I have to color an individual rectangle based on the value of an individual post, I know I need to get the value of a specific element in that 2D array. So I have get, where is it? Get element there on line 31. I also know that I don't want to be bothered with making a real live terrain map, so I made this make a random map method. Now, based on its name, what do you think it makes? A random map. If you were to do this for real, you would actually have your terrain data in a file, and you would have a method in here that loads a map from file. And I would call that method load map from file. And that way you could have, real live terrain data. better looking terrain data than random stuff. Okay, then we need the GUI. And here's the thing that I tend to do. Remember, you make your nodes, you put your node in a pane, you put the pane in the scene, you put the scene in the stage, right? And when you're making the nodes, you're going to tie some kind of an action to them. Well, since you're tying some kind of an action to those nodes, what I like to do, and you'll see this in several examples that I have, plus the author's examples, I like to take the pane that goes into the scene, I like to take that pane and actually build it as its own class, separate from the rest of the GUI. So here I've got my top level GUI, and it's awfully short too. All it does is create a pane, put the pane in the scene and the scene in the stage and show it, and that's it. All the dirty work is done here in the map pane class. So I've actually got, now you're really getting into this nice separation of model view controller. I've got my model down here in the post map, an array of 2D array of numbers. I've got my view up here at the top level, show me the pane that has the rectangles in it. And then I've got this intermediate thing that has the controller in it. And so this is where all the dirty work is. I believe it's a good object-oriented is all about segregating functionality, segregating jobs so that you can isolate them, so that when you try to understand what's happening, you only have to deal with a small number of things at a time, right? We're taking that large problem and we keep carving it up into small problems. So here I build my own pane called a map pane, and it extends just a normal old pane. And what does this thing have as attributes? Notice I need to know the height of all the posts, so I make an object of the post map type, of the post map class. And I need then to also make a 2D array of rectangles. And there I've got my one-to-one correspondence. So I've got an array of numbers in the post map, an array of rectangles are going to go up on the screen. And then this is just rectangle size, water level. I've just, threw those in there so that I could make this random map easily. And then if you look, here's my constructor. Whenever I make a map pane, first of all, someone has to tell me how many rows and columns. I actually think I did a column row form, which is bad, right? Rows and columns. And then my constructor tells you what it does. I don't put, my recommendation to you again and again and again, don't do your work in the start method. Don't do your work in the main method. Here, the constructor, similar thinking. Don't do all your work in the constructor. It's too confusing. But if you just read those 4 lines of code, you probably get a good feeling for what's happening. Make a random map, create the rectangles, color the rectangles, and then color the water level. It reads like a story, if I did my job right. And if you need to know what the details of each of those are, you can go to those methods. This is my recommendation on just how to do programming style. How when you guys are building your projects, you can get lost in these giant methods that are doing all kinds of stuff. Make your methods do one tiny little job and then make a lot of them. And life gets easier, right? Then you use those methods. So 4 simple steps. Make a random map. That's already a method that I created down here in PostMap, right? Make a random map. That's pretty simple. I've got a nested for loops. And I just randomly put the heights in. That's it. So I call that method, then color the rectangles in pane. What am I going to do? What do you think that's going to look like? It's going to be a nested for loop. And what do? Here's the value of the post in the post map. Therefore, here's the value of the color of the rectangle. That's it. And if we look, that's this mess down here from 58 to 76. I go through the doubly nested loop. I grab the value, the height of that map element, and then I used a switch statement because it just looks better, and I set in values. And I did an RGB value, whatever color value you want, it's fine. I spent way too long picking out the colors. And then once I did that, I'm sorry, that was color of the rectangles. Creating the rectangles in the pane was easy. All I did for the creating the rectangles, there we are, create rectangles in pane, doubly nested loop. And all I did is I colored them black edges, white middle, and I added them as individual rectangles to the, added those as individual rectangles to the pane. What's this mess about here on line 48? That's just getting positioned. So, you know, if you're the ith, jth rectangle, then I need to position you, you know, I units over and j units down, or j units, I units down and j units over, whichever I did there. It's XY, so it's I units over and j units down. And then its length is R size. So remember, for a rectangle, how do you make a rectangle? It's XY location for the origin, length, height, width, height. Did I have to play around with that to convince myself I got it right? Yeah, of course. But I'm only playing around with 4 lines of code. So when I built this, the first thing I did is made a bunch of white rectangles with black outlines. Why did I make them with black outlines? So I could see them. I made sure I could line them up the way I wanted to. Then I went through and made sure I could color them. And I probably didn't even do map.getElement. I probably just put a random number in there initially before I called the map element, just to see if I could randomly create stuff. And that my switch statement was right? You do little methods, save, compile, run, save, compile, run, over and over and over. And then for color of the water level, all I do is go through, and sure enough, I get that. I have to get the map element value. That's the value of the terrain. Remember, I don't look at the color of the rectangle. I look at the map value. That's the height of the terrain. And I just see if it's less than or equal to the water level. If it is less than or equal to the water level, I recolor that rectangle blue. So it's fairly straightforward. And all this does is, all that did was show random rectangles on the screen. On Wednesday, we'll go to the interactive form and look at that code. And it's not going to change much. The only difference now is I have the ability to change the water level. So I get interaction, right? Simple interaction here. No animations yet, just simple interaction. And how do you think I changed this? The code that I had did not need to be rewritten, but I did add to it. Take a wild guess what I added.
Probably buttons with like a set water level.
Exactly, yeah. I added the 4 buttons, and to each button, I did that set on action, and I ran the color water level method with 0, 3, 5, and 8 as the input for the water level. That was it. So by building these things up slowly, right? Don't try to build everything at once. I'm gonna almost go against that rule in a week or so. Don't try to build up everything functionally at once. You may want to build your skeletons all at once. I encourage you to do that for testing purposes. But when you're building up your functionality, don't try to build up. I would never have built this thing from scratch. And look how simple it is. I would have never built the whole thing at one time. I would build that intermediate form where I'm just building. I probably did the posts first and use print statements to convince myself I could build posts. And then I probably built the rectangles, and then I tied them together with the static color, and then I added the buttons, right? So you do these in nice, simple phases. Okay, we're at time. I'll let you guys go. Have a great day. And any quick questions before we go? All right. Have a good one.